This short video is to go over how we will in class be finding the inverse of f of x equals 2 to the x. So f of x equals 2 to the x. And if you recall, this is going to go back into our section on inverses, that the first thing we want to do is replace our f of x notation with a y. Okay, we don't want that. It's f of x notation is great, but it's kind of clunky here. And then because inverses are where we switch our inputs and outputs, it's literally where on our ordered pairs we switch the x and the y coordinates. So we are going to do that with the variables. So we'll switch the x and the y. And now we solve for the new y. So if you need a little refresher on the steps here, here's what we're doing. So replace f of x with y, that is just what we're doing. And then we switch x and y. And if you have multiple x's, you will now have multiple y's, but we don't in this case. And now we solve for the new y. Okay, so now we're going to solve for y. Now, like up until this unit, when we've been studying exponentials and logs, you would not have a way to do that. But now you have a way to do that. So if we want to get y by itself and y is trapped in the exponent, then what we will do is we will change to a logarithm. And so that would become log base 2 of x is equal to y. And then the last thing we want to remember to do, now we don't have to do anything else here. So there might be a problem where you need to like divide or add or subtract when you get to this point, but you want to take each problem individually. And now we would change that notation. So we would remember, okay, this is an inverse. So the inverse is log base 2 of x. And what the next step is going to be is for you to take, not that, there we go, is to take this function and then graph it with this function and observe the symmetry of the graphs. Observe your input output. So if the point, like say 0, 1 is on the graph of 1, then the point 1, 0 should be on the graph of the other.